Effective system administration relies on precise disk monitoring. Two fundamental utilities, df and du, provide the visibility needed to manage storage capacity and identify consumption patterns. The df utility, or disk-free, operates at the file system level. It queries the kernel to report the total capacity, used space, and available blocks for every mounted partition on your system. In contrast, du, or disk usage, functions at the file level. It performs a recursive traversal of directory trees, calculating the cumulative size of individual files and folders to provide a granular view of where data resides. The core distinction lies in their perspective. df tracks mount points and overall file system health, while du tracks the specific file tree structure. One tells you the state of the container, the other tells you the weight of the contents. Use df to monitor system-wide health and prevent partition overflows. Use du when you need to perform forensic analysis to locate disk hogs and reclaim space from bloated directories. We begin by clearing the terminal screen. This is a standard practice to remove previous output and maintain a clean workspace, ensuring that the results of our upcoming disk usage and file system commands are easy to read and focus on without distraction. The df-h command displays disk space usage for all mounted file systems. The -h flag is crucial here as it converts raw byte counts into a human-readable format, such as gigabytes or megabytes, allowing you to quickly assess available storage across your system partitions. By adding the -t flag, we extend our disk report to include the file system type. This is particularly useful for identifying whether a mount point is using X4, TMPFS, or other specialized formats, providing deeper context into how your storage is structured and managed by the kernel. Now we use du-h to check the size of the /etc directory. The -s flag provides a summary, preventing the command from listing every single file inside, while -h keeps the output readable. This is an efficient way to check the footprint of your system configuration files. To investigate the /var directory, we use the max-depth1 flag. This limits the output to the top-level subdirectories within /var, which is perfect for identifying which logs or cache data are consuming the most space without getting overwhelmed by deep file structures.
We can combine commands using a pipe to refine our view. Here, lists every file and etc., and piping it to head and end 5 foot restricts the output to just the first 5 lines. This technique is invaluable for quickly inspecting the contents of large directories.
Finally, we run df-i to check inode usage. Inodes are data structures that store metadata about files. If you run out of them, you cannot create new files even if you have free disk space. Monitoring these is essential for maintaining system health on high file count servers. To get a more granular look, we can list individual files. By piping du-us/etc into hev, we display the first 5 items in the /etc directory with their sizes, which is a great way to quickly spot large files in a configuration folder.